So any doubt in how this entropy is used as a spreading criteria? It's clear, right? Everything is just you apply the formula and multiplied by the probability of each of the variables, each of the values of the variable. Okay. So here age has three values: youth, middle age, and senior. So just look at the probability of each of them and multiply those probabilities with the entropy of the case. So Ginny will not cover today, maybe some other time. Okay, just instead of minus P log P for entropy, use the formula 1 minus Pi square. Okay. So where Pi is the probability of that particular value, that particular in that particular case, what is the probability of the yes or no? Okay, how many of them are yes and how many of them are no? So for yes and no. So as we saw earlier, when you split on middle age, you can see that all the 4 classes are yes, right? So when such case happens, then you can directly create a leaf node here and say class is equal to yes. Okay. In other cases, you can see that there is a mix of classes, and so you're not yet certain. So you have to make some more decisions. So you will grow the tree further downwards in those cases. Okay, and to grow the tree, you have to know based upon which attribute should now we make a decision, right? And where that is where these selection criteria come into play. So right now we are using entropy. So again, the entropy will be calculated for the attributes which are there now. So here you have income, student, and credit rating, and then based upon the which is giving the maximum gain, or you can say minimum entropy will be selected, and you will continue like this. All right. Okay. So that is fine for theory, but what happens in practice? Let's look at. Okay, so let's look at this particular table again. Okay, so it has a lot of, you can see it has a lot of attributes which are not numeric. Okay, and many times the tool that you are using, such as the Python or scikit-learn library that you are using to create decision tree, they expect the values, the attributes to be numeric in nature. They should be numeric. Okay, in certain cases, other cases, the tool may accept even categorical variable or nominal variables, whatever you have, like you have here, but at least Python doesn't accept that. You need to convert this into some different some numeric value that the Python can work upon. Okay, so here let's take example of age. Okay, so age has say youth, middle aged, and senior. So 3 values are there: youth, middle aged, and senior. So how can you convert this into a numeric attribute that gives information that that makes sense basically? So can you tell me how? You can just type your suggestions how this age variable or the feature attribute age has 3 values, right? Youth, middle aged, and senior. Okay. And you cannot say that senior is the highest priority or youth is the highest priority. You cannot say that, right? So even though it is kind of ordered in case of in age, but how will you represent this into some numerical format? What kind of range do you want to would you give? Okay, So someone is saying assigning rank or numerical range. So what kind of range? Can you give it value like say 1 2 3 or 0 1 2? There is 0 for this, 1 for this, and 2 for this numerical values, direct numerical values. But then the system, if you do like this, the system will assume that okay, the value for senior is double that of middle aged, okay, and that youth has 0 value. Okay. And that's problematic, right? It is kind of giving the maximum weightage to senior if you do like this, and the minimum to youth. Or if you do 2 1 0, in that case the maximum will be for youth and minimum to senior. So converting of attribute directly to numeric like this in any order you want or in any form you want has problems, right? Because the system will consider these as the way as numeric values, okay, and accordingly it will try to create the decision tree. It will assume that okay, in this case senior has value of 2, so wherever it's trying 2 is more than 1, right? 1 more than 0. So we try to do something like that. There are 3 values. So it will give some ordering, right? If you had, so let's say if you only had 2 values, let's say age had only 2 values, or is there anything here that has 2 values only? Yeah, student. Let's say a student. It has only 2 values. No and yes. Okay, no and yes. So in this case it's fine. You can give 0 to no and y to 1. Okay, and the system understands that is a binary variable. But you have to tell that it's a binary variable, that is not consider them as numeric. If it is 0 1 binary, that is fine. But 0 1 2 is not binary anymore, right? It is something numeric. So how do you convert? In what other way can you convert this? Okay, so the idea is here. Idea here is to use something called one hot encoding or a dummy variable. Okay, so for youth, you have one value youth, you have one value middle aged, and one value senior. Okay, there are 3 values for age. Okay, so what you will do is that instead of keeping a single variable age, you will create 3 dummy variables here. Okay, so one dummy variable will be for youth. So wherever you have youth in the example, you will keep 1 there. Okay, and middle and this will be 0 0. In all the examples, wherever youth is, whether age is youth. Okay, and in the examples wherever the middle, whenever person is middle aged in the example, you put 1 there, and remaining will make 0 0. Okay, and in the examples where you have senior as the age, you will keep 1 there, and remaining 2 will make 0 0. Okay, so it's called one hot encoding. And it's only one of them. One of the variables have value of 1, other value will be 0. Okay, so in the examples where the youth is, when the age is youth, the value should be 1 0 0. If the person is middle aged, the 3 dummy variables will have value of 0 1 0. If the person is senior, then the variables will have value 0 0 1. Okay, but this still there is some problem, that is okay. Sorry. So there is still some problem that is called something called collinearity problem in statistics. Okay, in which if one of the variable is dependent upon some combination of a different variable, It's called a collinearity problem, and systems, the accuracy of systems may decrease because of collinearity. Okay, so that's, just remember that, you don't have to go into detail. But whenever one of the variable is a combination, it can be presented as a combination of other remaining variables or some other subset of variables. You say there is a collinearity problem. Now in this, there is a collinearity problem because if you know any two of the variables, let's say you know middle, you know the value of these two variables, that is for the middle aged and senior. Okay, so you have created three dummy variables here. Okay, one corresponding to youth, one corresponding to middle aged, and one corresponding to senior. And let's say you know the value of middle aged and senior. Let's take the first example. You know that middle age bit is 0 and the senior, that bit is also 0. So obviously the third bit, that is youth, should be 1. You know that, right? Because only one of them is 1. It's one hot encoding. Or let's take the second example. If middle age is 1, senior is 0, you know that is, you know y should be 0. This is obviously you can get. So you can see that you can find out the value of any of the one variable if you know the value of other two variables. Okay, and similarly for the third case, if you know that it is 0 1 for middle age and senior, bits are 0 and 1, so you know that corresponding bit for youth should be 0. Okay, so in fact here the one of these dummy variables is redundant. Okay, it is just introducing collinearity in your data set. Okay, so in practice you have to discard one of the dummy variables and use only 2 in this case. Okay, or if there are n or there are say k different possibilities for any attribute and you want to convert that attribute into dummy variables, okay, and that attribute has k different values it can take, then you need only k minus 1 dummy variables. Okay, so in this case you had 3 values for age, so you need only 3 minus 1, so 1 less than 3 is 2, so you need only 2 dummy variables. Okay, so that is the idea behind dummy variables. And out here, so you, instead of single variable age, now you'll use 2 variables. Okay, because you remove one of them. Dummy variables, one of the dummy variables is removed out of 3, so you will use 2. Okay, and Python or any other tool of significant, they provide such APIs which will help you to discard one of the dummy variables in for such cases. Okay. All right, now let's look at a particular example. Okay, while you are doing this, can you run this command conda install python dash graphics? We'll just run this command. It will install the graphics, this package, Python graphics, that is graphics package, which can be actually visualize. You can visualize the decision tree. The tree can be visualized by using this. Okay, so it's a very nice tool. So just download this package, Python graphics. It will take some time to download. Okay, for me it took like 1 hour. So just to download a lot of packages and then fix the dependencies and all that thing. So it takes time. Okay, but download this anyway. Okay. So what I'm doing here is, so I've written this code just for this purpose, this same example that we have been looking in theory. So the same corresponding code I've written here using this Python data frame. So These are the 4 attributes: age, income, student, credit rating. So I'm only using the first character. So for youth I'm using Y, for middle age I'm using M, for senior S. Okay, for the age attribute. For income I'm using HML, initial character, first character. For student NNY, and for credit rating FE, and for class I'm using N or Y characters. Okay, so I'm using just characters here. So these are the 4 attributes that I'm putting in a data frame. Okay, that you know already how to create a data frame. So you can also actually read from a from a file, but right now I'm not done that. I'm directly using that. I'm creating data frame in this the program itself. Okay, so maybe I will just share because now the graphics is. And one more thing, you may not need to install this graphics package. Okay, if you install Python graphics, I think this graphics is automatically installed. Okay, if there's some problem, you may have to include path sometime. Okay, like it happened in my system, one of the systems, I had to also include the path. Okay, if some problem comes, then ask me. I will just reply in the forum, the course page. Okay, so I'll share my desktop so that you can see how the program runs. Okay, so I've already copied this here. Same thing. So I've already run this command in the system and installed the package. Okay, so in this right now I think I'm not using this data frame df. Okay, so you might not have to use this df. We can remove. Okay, let's do it. Okay, so in this button is basically creating a data frame, and then adding 2 test cases. So these are the 2 test cases that I just added to check what is the output of this. Okay, but in this code right now I'm not actually testing it. I'm only creating this entry. Okay, I'm not yet used predict in this case. So it's there in the system, but it's there in the table. So I'm appending these 2 test cases to the data frame, so that whenever the dummy variables are created, okay, the same dummy variables have to be created for test data also, right? You cannot have different number of variables in your training and different number of variables in your test. So they should have exact same variables. Okay, so that means for test case also, for the test data also, you should create dummy variables, and so that's why I'm adding the test data, the 2 test cases here. So I'm just appending that to the original data set. So data is my original data frame, to which I appended this data frame, which consisted of the test set. Okay. Okay. So in this you can see that there's a get dummies. Pandas has this get dummies function that will actually create the dummy variables for you. Okay. So you only have to give it the name of the data frame for which you want to create dummy variables. Okay, and you can create dummy variables for all the non-numeric variables or non-numeric attributes. And here drop first is equal to true. Okay, so why I'm setting this, because I want to remove one of the dummy variables created. Okay, so this particular flag drop first is equal to true will drop the first attribute or first dummy variable. Okay, you can drop the first one because it's a combination. It can be found by the other. So it will create dummy variables and save that in FEA. FEA is, again, you can say it creates a data frame which will consist of the attributes in this data frame will now consist of the dummy variables instead of age, income, student, credit rating. Instead of this, it will now create dummy variables for us. Okay, so maybe I'll print this here. Print FEA here. Okay, so this FEA, this will print the dummy variables. Okay, some question. Dummy means it is not actually. So what is the dummy variable mean? There's a question. It just means it's a variable. It's a binary variable with values 0 and 1. Okay, and it is created in place of a categorical attribute. Okay, for categorical attribute to convert that into numerical variable or binary variable. Okay, so for depending upon how many values an attribute categorical attribute takes, you'll create -1 of that. Okay, that value -1 dummy variables. So this is one hot encoding. Alright, so here it is. You can see. So this is the. Okay, maybe I'll just. Okay, yeah. So you could see here the age had 3 values, right? Y, M, and S. Y, M, and S. So M. So in alphabetical order, you can see it was M, S, and Y. So I think it is just in alphabetical order. It is just dropping one of them. So M had been dropped. Okay, and remaining 2 are here. So for the first example, what are the first example? Let me check the first example so that we can just look at the corresponding variables here. Okay, yeah. So the first example, was age youth. Okay, in the first example, age was youth. So look at the corresponding values. You can see that in the dummy variable, the age Y corresponding youth, each one, and age S is 0. There must be one more dummy variable, that is age M, but it has been discarded. Okay. Then credit rating. Now, how many values were there for credit rating? They were fair and ex. There were only 2 values. Okay, so 2 dummy variables were created, but it rejected one of them because that was direct. You can get it directly from the other value. So for credit rating, it's fair and excellent. So fair E and F, right, in alphabetical order. So E was discarded and F remained here. So first one was fair. First one was in the first example. You can see that its value is fair. Then after that, the next one is income. Okay, now how many different values does income have? High, medium, low. Okay, and in alphabetical order it is H, L, M, right? So H must have been discarded. L and M remain. L, M remain. So L, M, income L, income M, income L, income M. So the first example here have income H. Okay, that means the remaining 2 variables should be 0. So L and M must be 0, 0 here. Okay, so 2 are 0, 0 because the one with 1 had been discarded. The value, the dummy variable with 1 has been discarded. Okay, but because the other 2 are 0, you know that the third must be 1. And then you have student, yes or no, student N, Y. So N had been discarded. So first one is student no. That means the student n must have been 1. Okay, but here it has been discarded. So student y is the dummy variable remaining, and its value will be 0, and that is the case. Okay, so same thing, just representing in a different way. Okay, and now when you do all the splitting attribute selection criteria, you will do this based upon these new data set that you have that consists of the dummy variables. Okay, so instead of the very simple age, income, student, credit rating, if your tool had that capability, okay, if it has that feature in which you can directly use categorical variable, very good, you can directly use that. But here Python doesn't have it. Okay, so you use this dummy variables. Okay, now you will use the same method. So what we'll do is we'll just do an exercise. Okay, and okay, let me just show you the output that has been created. Okay, the tree that has been created. So it will save it in a PDF file. So it's basically just this is just saving it in a just code for saving it in a file. Okay, creating a decision tree graph and saving it in a PDF file, and I'm calling that biascomputer.pdf. bias_computer.pdf. So here dt is the decision tree. Okay, dt.fit will create the model. Okay, as we have discussed earlier also, fit it will create the model for any classifier. We just use fit on some data set. It will create that the model. In this case, it's a decision tree model. Okay, so here df train is the first 14 variables, because remember we added 2 test cases also. So after adding 2 test cases in our data frame, it becomes total of 16 examples. Okay, and first 14 were only required for training. So df train, I used only the first 14. Okay, first 14 for df train and the last 2 for test. So test we are not yet using, we are only using df train. Okay, so okay, so here it is, the decision tree that has been created based upon the dummy variables. Okay, so some time to open. So this is a decision tree which has been created based upon the new data set that consisted of the dummy variables. Okay, so let us just look at one particular path. Let's take one particular path and see how this is working. Okay, so it is no, yeah, right. So let's look at this particular path, the leftmost path, okay, leftmost one here, and one table is here. So let's open this together. Okay, is it visible? So can you see both the windows side by side? The table as well as the, yeah, okay. So let's look at the leftmost path. Okay, whenever you are starting from the root node and then going to the left side. Okay, let's take that path and see what happens, and we'll see the corresponding value in the table. Okay, so in this case, student y. So the first line in each node correspond to the condition that is checking. Okay, so it knows that the first criteria, the first attribute that should be selected based upon entropy criteria. Okay, one thing that I didn't mention was entropy. You can see that criterion is called entropy is written here. Okay, whenever you are creating a classifier here, so I mentioned criterion you want to use entropy as a criterion. Okay, by default in scikit-learn it is Gini criteria. Okay, but here you want entropy. Okay, so student y, so student have values 0 or 1. Remember, so less than or equal to 0.5 means is 0. Okay, student value is 0, or student y value is 0. So no, not here. We have to look at different case. We have to look at the new data set. This one. Okay, so student less than 5 means 0. Okay, so left side is true, right side is false in all the examples, in all the in whole this in this diagram. The left side means true, right side means false. Okay, so student y is 0 is true. That means student y value is 0. So student y is 0. So there are multiple such examples where student y has value 0. Okay, then left side age y, second student idea is age y is 0. So age y is 0 means so we have these two examples with age y as 0. And any other example? Yeah, and we have one more example of 11 where age y is 0, and then one more 13. Okay, so 2, 3, 11, 13 right now are still satisfying the criteria. Then next left side is credit rating f is equal to 0. Okay, so credit rating f is equal to 0. If you look at the third node left side, so the third criteria is the condition is checked on credit rating is 0. So credit rating f is 0. So which one of them is has this? I think okay, this one is number 11 has is satisfying this, and as well as number 13. So 11, 13 are still satisfying all the criteria. Then age s is equal to 0. Okay, now 11 is satisfying. Age s is 0 for 11, isn't it? Now if age s is 11, then you get entropy of 0, and the class will be y. Okay, let's look at what is the class of this example. So the here you can see that the serial number is starting with 0. So this is actually a 12th example. Okay, it's actually 12th example, and it is yes. Okay, you can see that the class is yes. So for the 12th example, class is yes, and so it will give you s only by reaching leftmost node, and entropy becomes 0 because all the examples at right now they belong to a single class UI. Okay, so the blue nodes in this example, they kind of they mean the class is yes, or the majority class is yes, and the orange nodes leaf nodes, they mean it is the majority element are no. Okay, and if it is equal, it is white. Okay, so it's like they are equal in number. So you can see that in this particular node is as this particular node, both the samples were equally divided, so it is white in color. So this is nice color scheme here. Okay, so I'll stop sharing this desktop. Any doubt so far? Okay, so now let's do an exercise and find out how this particular diagram was created. Okay, there is a question: how will you refer Excel file with the same data in this program? Oh, you have read CSV and other APIs are available. Okay, I think some Excel also you have some APIs to read Excel files. Okay, I have not tried that myself, but you can just search online. You get the idea. You can read actual Excel file. So there are APIs available for that, for reading Excel file. All right. So okay, one more thing. If you want to replicate your experiment, you want to show something, you want to show that exact same thing is repeated. Then remember, I told you that you have to set some seed somewhere, right? Some seeding. Now here, because we didn't use that seed, you can see that the diagram that is in the slide is different from the diagram that was created when we run the program right now. Okay, and when you run the program again, it might create a different diagram. Okay, depending upon what are the seeding. Okay, so based on those seeding, some random numbers are generated and it's done. Okay, so if you want to replicate the program, always use some seed. Okay, in this case, the seed is, you can give it as a random state in the decision tree. Let me just check. Okay, so random state is there as a variable. I'll just copy it. Okay, so in this decision tree example, you have to give comma, random state is equal to some number, okay, maybe 0, 1, 2, whatever you wish. Random state equal to 1 or 10, whatever. And then use the same random state if you want to replicate the output again. Okay, otherwise, you might get different output when you run the program at different time, like we just got here. Okay, so this was in the PDF, in the PPT, the diagram is different, right? When you run the program, the diagram was different. There was more elements on the left hand side. Okay, so this happens. Anyway, so the output still will be correct. Okay, it doesn't mean that output will be wrong, but because when you have multiple possibilities, okay, when you have multiple possibilities, then which possibility should be taken? Okay, if you have a random variable, if you have that fixed random state or fixed seed, it will always take that particular route, a particular route. Okay, otherwise it may take any route randomly. So student y, age y, age well, anyway, so let's look at this particular case. Can you use the splitting criteria now? Let's look at age s. Okay. So what will be the entropy if the split was on age underscore s? Age underscore s. What will be the entropy? The split was done on age underscore s. Now remember, they are all dummy variables, so they have only two values, 0 and 1. So just look at how many of them are 0 and how many of them are how many of them are 1. So there are 3, 4, 5, 6, 7, 8, 9. So there are 9 zeros and that means 5 ones are there. Okay, 9 zeros and 5 ones. So what is the probability of 0 getting selected? 9 by 14. Okay, 9 by 14. And provided that this has been selected, what will be the entropy if the 0 is selected? So 0 means this one, first one, second, third, okay, then 7th, 8th, 9th, and 11, 12, 13. So these are the 9 examples with age as 0. Okay, so among these 9, what is the entropy now? Just find the entropy among these 9. So there are how many n's are there? How many s are there? So how many s are there? 1, 2, 3, 4. Oh, sorry. 1, 2, 3, 5, 6. There are 6 yes, right? That means entropy will be minus 6 by 9, log 6 by 9 for yes, and for no it will be minus 3 by 9 log 3 by 9. Okay, so this is for zeros, as well as you find for ones. Okay, so when you do this, so you get the entropy for age s as 9. So I have done this actually manually, and I found that the entropy for age s was 9371.9371. Okay, so among these, the minimum entropy is for student y, 7884. Okay, so the first split will be on student underscore y, and according to the diagram also, it is on student underscore y. Okay. Now once we have split on student y, let us take a particular turn. Let's say take left turn when student y is equal to 0, 2. Okay, so these 4 have student y 0. So now I only take those elements or those rows or examples from the table which have student y 0, because we want to just try for that case. Okay, so that I am taking the values from the table or the rows from the table with student y 0. Okay, I made this row or this particular column as red line, means we don't have to now consider this column. We should not consider this column. This is already been done for splitting. Okay, so now remaining 1, 2, 3, 4, 5. So there we have remaining 5 columns, 5 attributes, and we have to find the best among these 5. Okay, and after calculation, I found that age underscore y have the minimum entropy. So next should be age underscore y. Age underscore y is the next according to the 3 also. Okay, now in the next diagram you'll see that I made the age underscore y. Okay, and I'm only looking at that 0 part. I'm only looking at when age underscore y is 0. Those are part in the table. So in this table, I'll only look at those rows which have age equal to 0. So 1, 2, 3, 4. Only these 4 remain with age 0, right? Age underscore y 0. So this is the table. Now again look at the remaining attribute. So after that, age underscore s has the minimum entropy. Now here you have. So remember what happened. There were 2 cases with the minimum entropy. Age underscore s and credit rating underscore f. Both have minimum entropy of 0.5. Now which one of them will be selected? You can select either of them, right? So if you don't use a seed random underscore state, then on different run of the program, different value can be selected, different attribute will be selected. So because it doesn't matter, right? So in this case, in the PPT, you see that it selected age underscore s. Okay, but in the run, when we run the program, it selected credit rating F. Okay, because we didn't have any seed, we didn't use the seed. Okay, so here you can use either age S. So in this particular case, let's continue with this in the PPT. So age underscore S is selected. Okay, and then again to take the left turn when age S is 0. So age S is 0 in 2 rows. So you can select these 2 values, these 2 rows only. And you see that once you come here, once you reach here, there are 2 examples with age S 0, and both have class as Y. Okay, so when age S is 0, the class should be Y at this point of time. You can see that this is the place, right, where both the examples are positive. When age S is 0, the class will be Y. Okay. On the other hand, if let's take one more example, when right hand side, but the age S is not 0, that is right hand side is taken. So again you have to continue for the remaining attributes. Okay, so when age S is 1, now you have 3 remaining attributes, so only one of them has to be selected. Okay, so that's with the minimum entropy, and here you find that credit rating F has the entropy of 0. Okay, credit rating F has entropy of 0. If you split on credit rating, the entropy will be 0 because both the examples have clear cut Y or no's. Okay, so here we split on credit rating, you'll exactly get 1 for Y and 0 for N. So next is the credit rating. On the right hand side, after age S, it will be credit rating, and in the diagram also you can see that on the right hand side it is credit rating that is used to split. Okay, so once you split on credit rating, yes, okay, you see that the entropy for either case becomes 0 because now whether you have 1 or 0, it doesn't matter, you only get class as Y. Okay. Okay, any doubts? I think we are running out of time. So if you have any doubt, please ask. Any doubt in understanding the theory or understanding the code for decision tree? Let me know. Okay, no doubt. Okay then, thank you very much. So tomorrow there is no class. Okay, we'll meet next Saturday.